Gosh, it scared me to death. Maybe the derivative of a function of a real variable measures the sensitivity to change of the function value with respect to a change in its argument. Wait. Oh, wait! Maybe I can ask for a help to a stranger. Oh, there's a guy over there.
What's the problem?
Problem in this situation. I don't know how to solve derivatives of a function.
That's easy. I'll teach you how. So, what do you know about derivative of a function?
Well, I know about this.
Let f be a function defined on an interval I is less than or equal to r, and let x be an element of all real numbers of I. The derivative of a function at a given x. Defined to be f of x is equal to the limit of x plus delta x minus f of x all over delta x as delta x approaches to 0. And that form we have is what we call instantaneous rate of change. And the triangle figure we have is what we call delta or change. Now to make it average rate of change, we are now going to disregard the limit. So it would be f of x is equal to x plus delta x minus f of x all over delta x. So in solving derivatives, we may encounter these variations of notation such as prime notation, subscript, and Leibniz. So for prime notation, we have f prime of x and y prime. For subscript notation, we have f of x with respect to x. And for the last one, Leibniz notation, we have derivative of f of x with respect to x, or simply d f of x dx. And another one of that is derivative of y with respect to x, or dy dx. So for example number 1, we have f of x is equal to 2x. But should we substitute it directly using the form of limit of f of x plus delta x minus f of x all over delta x as delta x approaches to 0? Or will you substitute the given f of x to delta or only the x? Now for our examples 2 and 3, we have f of x is equal to negative 3x plus 4 and f of x is equal to x squared.
So to find the derivative of the function 2x, we use the formula f prime of x is equal to the limit of f times the quantity of x plus delta x minus f of x all over delta x as delta x approaches 0. So f prime of x is equal to the limit of 2 times the quantity x plus delta x minus f of x all over delta x as delta x approaches 0. So we distribute 2 to the quantity of x plus delta x. So we get 2x plus 2 delta x minus f of x, which is 2x, all over delta x. So we can cancel out like terms, which is the 2x. And we are left with 2 delta x all over delta x, in which delta x over delta x is equal to 1. So 2 times 1, we get the answer 2. And that is the derivative. So to get the derivative of the function negative 3x plus 4, we'll use the same formula. So f prime of x is equal to the limit of negative 3 times the quantity x plus delta x plus 4 minus f of x, which is negative 3x plus 4 all over delta x, as delta x approaches 0. Next is f prime of x. We distribute negative 3 to the quantity, so it's negative 3x minus I said 3 delta x plus 4, and we distribute the negative to the function, so it's plus 3x minus 4 all over delta x. Then we cancel out like terms, negative 4 and positive 4, 3x and negative 3x, and we are left with negative 3 delta x all over delta x, in which when we divide it, it will become negative 3 times 1, which is equal to negative 3. And that is the derivative of the function.
Now in answering number 3, we have f of x is equal to x squared. We can directly substitute x squared to the limit of f prime of x plus delta x minus f of x all over delta x, as delta x approaches to 0. And we have quantity of x plus delta x squared minus x squared. And first we must expand. So we have x squared plus 2x delta x plus delta x squared minus x squared. Since we have positive x squared and negative of it, we can cancel out them and all over delta x. So we have 2x delta x plus delta x squared all over delta x. So after that, we must factor it out. Wait, I think I am factoring wrong. Isn't this right? I think not. Now when correcting our factoring, we must factor out delta x times 2x plus delta x all over delta x. Since we have delta x on the numerator and denominator, we can cancel them out. Okay, so we have 2x plus delta x, and since we have this left, we can directly substitute 0 to the delta x, and 2x plus 0 is equal to 2x only. That's what we have.
So thank you very much for your help, sir.
Anytime. Oh, hey, I didn't see you there. Well, since Kim was able to solve the derivative problems, I bet you can also do the same. Here are some problems. So pause the video and take your time to answer it. So after solving the problems, I will now show you the solutions.
So in answering derivatives, we must always remember that before we start, we must first be familiarized with the formula, which is the limit of f of x plus delta x minus f of x all over delta x as delta x approaches to 0. And also with the variety of notations we may encounter, like prime, subscript, and also Leibniz notation. For the last one, we must always remember that by any instances of solving derivatives, we may encounter some equations which in need of factoring, especially for the larger set of numbers. Like what happened to me a while ago, in answering number 3, I didn't check my factoring first. That's why, if I continue with that way, I might come up with a wrong answer. Meaning, every part of solving is important to end up with a correct answer.
Merry Christmas!
Oh, and a Happy New Year!